Since the day we began gazing at the sky, the question, are we alone in the universe, has puzzled humanity. Thanks to this curiosity, our quest has grown since the invention of the first telescope, which allowed us to take a closer look at the stars in the sky. As we approached the present day and began to understand the universe better, another question emerged. How did life begin? Starting in the 20th century, with the help of rockets, we began to explore everywhere we could reach in order to satisfy our curiosity. From studying the moon, we moved on to examine Venus's atmosphere and its surface, which is hot enough to melt metal. We sent countless probes to Mars, starting with the Viking missions, exploring mountains and valleys to search for life or at least traces of it. So far, we haven't achieved any conclusive results, but we haven't given up searching either. To unravel the mysteries of our solar system and discover potential clues to life, NASA has embarked on a mission to explore Europa, Jupiter's ice-covered moon, which is considered one of the most promising places where life might exist. Welcome to Spaceship Earth. In this video, we will discuss the Europa Clipper probe launched to study Europa, one of the rare places in our solar system where life might be possible, the journey it's undertaking, and how it will study the oceans hidden beneath kilometers of ice on Europa. The Europa Clipper probe was launched on October 14, 2024, from the Kennedy Space Center in Florida aboard a disposable Falcon Heavy rocket. Once it reaches Jupiter after a 5.5-year journey, it will aim to change our view of the solar system and life. Scientists consider liquid water one of the essential conditions for the existence of life as we know it. In our solar system, 3 planets fall within the habitable zone, where water can remain in liquid form without evaporating or freezing: Venus, Earth, and Mars. The other planets in the system are considered too cold or too hot for life to flourish. Humanity initially focused on this green zone in its search for life. Nowadays, however, researchers are targeting Europa, one of Jupiter's moons, where liquid water is believed to exist, even though it lies outside the habitable zone. Unfortunately, Europa is not a very appealing place to conduct research. The giant planet it orbits, Jupiter, makes research and even survival in this region extremely difficult. Jupiter, the largest planet in our solar system, is sometimes described as a planet that couldn't become a star. The massive planet's magnetic field is 20,000 times stronger than Earth's. This powerful magnetic field, combined with particles ejected into space by Io, perhaps the most geologically active moon in the solar system, creates a lethal environment. Tons of ionized material ejected from Io's volcanoes are captured by Jupiter's magnetic field. As the planet spins, these accelerated particles form an enormous radiation belt that encompasses its moons. One of the moons subjected to this radiation belt is Europa. If you stayed on Europa's surface for just one day, your body would be exposed to 5,400 millisesvelts of radiation, roughly 700,000 times more than the daily radiation exposure on Earth. So why is NASA searching for life in a place where the surface is so inhospitable? It isn't, at least not on the surface. If there is a place on Europa where life could exist, it would be beneath the surface, and we know this because of Europa's uninhabitable exterior. When we examine the moons of planets, including our own, we see that their surfaces are usually littered with countless craters, but Europa has almost none. Its surface is relatively smooth for its size. Wondering why this was, scientists examined data from probes like Voyager and Galileo. The data suggested that beneath Europa's outer shell there might be liquid water, possibly more than in Earth's oceans. But how did they reach this conclusion? And how can there be oceans hundreds of kilometers deep in a place so far from the sun where water shouldn't remain liquid? The reason bottomless oceans can exist lies in Jupiter's massive gravity and complex moon system. Like all planets, Jupiter plays a gravitational tug-of-war with its moons. This gravitational tug becomes more complicated with the involvement of large moons known as the Galilean moons. During this process, Europa's core heats up due to friction and stress, causing the ice beneath its crust to melt and turn into liquid. This heating and pulling cause the ice on the surface to crack, and salty ocean water escapes into space through these cracks, gradually erasing any potential craters on the surface. The gravitational and thermal activity created by Jupiter and its moons is also thought to form structures similar to hydrothermal vents found in Earth's oceans. On Earth, hydrothermal vents are like underwater geysers formed in cracks or volcanic regions on the ocean floor. These areas are rich in minerals and serve as hotspots for intense biological activity. A life cycle, beginning with bacteria that feed on minerals and extending to fish, thrives around these vents. If similar hydrothermal vents exist on Europa, they could be ideal spots for life to exist on the moon. The Europa Clipper is equipped with various scientific instruments to search for potential signs of life. It carries 2 radars operating at different frequencies to measure the thickness and characteristics of Europa's ice layer. Additionally, 3 magnetometers will be used to map the moon's magnetic field. Through this system, changes in Europa's magnetic field will be observed, and the effects of the salty ocean beneath the ice on the magnetic field will be studied. The probe will also carry 2 different spectrometers to analyze Europa's thin atmosphere and the contents of any materials ejected from potential geysers during close flybys. These instruments will determine the chemicals that make up any samples that can be collected. In addition, 2 spectrometers operating in infrared and ultraviolet frequencies will remotely observe Europa's surface and conduct similar measurements. Furthermore, 2 cameras, one with a wide angle and the other with a narrow angle, will capture detailed images of Europa's surface. Depending on the camera used and the altitude, images will be captured at resolutions ranging from 100 meters to 50 centimeters, and 90% of Europa's surface will be mapped. However, not all of the moon will be mapped during the 4-year mission because Europa Clipper will not enter Europa's orbit. Due to the high levels of radiation mentioned earlier, almost all previous probes sent to the region have encountered problems. Even the Voyager and Pioneer probes, which passed by Jupiter briefly, were affected. The scientific data they collected became corrupted, and sometimes their flight computers issued incorrect commands. To minimize the effects of the high radiation surrounding the planet, most of the electronics on Europa Clipper will be housed in a 1-centimeter thick aluminum cage. Even this fortress wall, thick protective layer considered substantial for space operations, would only protect the probe for about a month if it stayed in Europa's orbit. To extend the mission's planned duration to 4 years, the probe will orbit Jupiter instead of Europa. It will enter an elliptical orbit around the planet, approach Europa to gather as much data as possible, then leave the dangerous radiation zone to send the data back to Earth. This way, the probe will fly by Europa 45 times during the 4-year mission, conducting scientific measurements each time. Having embarked on its 5.5-year journey, Europa Clipper is set to enter Jupiter's orbit in April 2030 and will begin its work to answer many of the questions we've been eager to explore. Bon voyage, Europa Clipper. Thank you for watching Spaceship Earth. If you found this video useful, please like and share it. You can support our channel by clicking the thanks button or joining by pressing the join button, and subscribe so you don't miss our videos about space and space technologies.